We are on page 28. Whew. So, you guys, I wrote some words here. The antiderivative of a function f is another function g whose derivative is f. To me, that is very not helpful till we put it into some context. Antiderivative just means an integral. The antiderivative, you guys, is just a big word for that sign.
X squared
Is of 2x is x squared because the derivative of x squared is what?
2x.
Yeah. So you guys, we're very used to walking forward and taking a derivative. You guys are so good at taking derivatives. Now we gotta walk backwards and get the antiderivative. Gah. The antiderivative is cosine because the derivative of what is cosine? Sine. The antiderivative of cosine is sine, or the integral of cosine is sine because the derivative of sine is cosine. Ooh, antiderivative of 1 over x. That one we haven't seen in a little smidgy. That one's natural log because the derivative of natural log is 1 over x. Good job, good job. So you guys, whose derivative is secant squared? Tangent. Now, you guys, how I always have to check these because you guys have been taking derivatives since September. So you're good to say, oh, is the derivative of tangent secant squared? You guys are good at that. We're not as good at going this way because we just saw this today. What's the derivative? You agree that the derivative of tangent is secant squared. What's the derivative of 10? 0. So is this derivative still that? Yeah. What if I said 101?
Yeah.
What if I said 101 pi?
Yeah.
Is the derivative of 101 pi still nothing?
Yeah.
Okay. What if I said 101 pi e?
Yeah.
Still a constant. So what we got to remember is when we take an antiderivative, again with no bounds to Dice's point, we need to add any constant to the end of it, which is very easy to forget. Does it make sense that the derivative of an integral would cancel each other out? Boom, 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 boom. And I'd be left with the function, but then we can't forget that plus c, okay? And does this make sense that the antiderivative of g prime, if I said, hey, is the derivative of g prime? Yeah. Is the derivative of constant 0? Yeah. You might be like, wait, why is that dx chilling? That dx is really that formality just to say we're dealing with the variable x. So let's practice this. Let's see what the heck we're talking about. The antiderivative of 4x cubed could be written as this. Instead of writing antiderivative, you down with writing the squiggle?
Sure.
You know what I'm saying? What do you think? Whose derivative is 4x cubed? Ooh, it's going to be nice. X to the 4th plus some constant. You're like, what is going on again? Is the derivative of x to the 4th 4x to the 3rd? Yeah. Is the derivative of a constant 0? Yeah, I feel good about it. So then I've got this hubbub. Gross. This is for my people who were like me, that you're like, dude, how are people thinking about this backwards? I wasn't good about thinking about this backwards. Ready, Nelson? Okay, here we go. So to your point, you're like, dude, I don't even see numbers here, right? Let's think real fast. What is this referring to? It's saying if I've got something written like a power rule, what do we do to that exponent? You added 1 to that. Did that 3 become a 4? Then what do you divide by? My new exponent was n plus 1. And look what I divided by. My new exponent, which was n plus 1. Did we follow that rule here without even knowing that we followed it? You guys, I'd have 4x to that. Add 1 to that exponent. 4. Divide by that new exponent. Do I get what you guys came up with? That's the cheat for antiderivatives. Give me 1 sec. You're like, okay, so you want me to remember we got to add 1 to the exponent and divide by my new exponent. I do. And you are going to remember because let's think back real fast. What if I said, how did we find the derivative of this? What did you do with that exponent?
Bring it down.
You brought it down. Were you multiplying by it? it would be multiplied. And then what did you do with that exponent? You took one away. So when we went derivatives, you multiplied and took an exponent away. Now when we go antiderivatives, we're adding an exponent and dividing. So it's literally the exact opposite of what we've been doing. So let's go take a peek, see. Let's go look at this first one. Can I add one to my exponent, y'all?
Yep. Yes.
That'd become 3x to the what?
Third.
Divide by that new exponent.
3.
What would you want to simplify that to be?
X plus C.
Thank you, Greer. He says, don't forget that constant, y'all. And what is that constant referring to? Is the derivative, you guys, do you feel better saying, is the derivative of x cubed 3x squared?
Yep.
Look at how quick you are at that. We're good at that. Is the derivative of a constant nothing?
Yep.
I feel good.
Nope.
You guys, I want to go down. We're going to go to 4. Whose derivative is cosine? Yeah, it's sine. Now, did we just do, as Dice pointed out, did we just do my exponent rule? Did I bring this up by one exponent and divide by a 2?
Yep.
I didn't, because this doesn't follow that power rule. You know what I'm saying? Can we do that here?
Yes.
I've got a -5. Bring that exponent up 1.
X to the 5th.
To the 5th, divide by my new exponent. What's my answer going to be?
Sine of x minus x to the 5th
Plus C.
Thank you, Sammy Reichert. Is this written like a power rule?
Maybe.
Yeah. Add 1 to that exponent. What does that exponent become?
X to the negative 1.
Divide by my new exponent. Great. So don't forget, ready? Oops. We had to always, just like you did over here, you added 1 to this exponent.
Oh, added. Yeah.
Yep. You guys, let's rewrite this because this is nasty. You guys, is 4 over -1 the same as -4?
Yeah.
So can I move that negative up? Yeah, I want to move that negative up. Where am I going to move this guy? It going down. What's its exponent going to become?
So just down.
Yeah, very good. It's just gone. It's going to be a +1 or just gone. What would I put up here then?
1.
Very good. So these are equivalent. You don't have to simplify it, but is AP going to leave this as their answer? No. This or, oh, no, that'd be if you took another antiderivative. Yep.
Plus C.
Oh, plus C. So we're saying my answer is -1 over x plus a constant.
Are we going to do
Take a peek
same?
here. I want us to change this problem though. Could you please make this over t to the 4th? To Dice's point, he's like, oh, sorry, Bonnie. Okay, you guys, let's take a peek at this guy. Let's go take a peek at this one. Dicey said this rule only applies when I have this written like a power rule. Guys, go add 1 to this exponent.
X to the 3rd.
T to the 3rd. What are we going to divide that by?
3.
3. Now, Miss Meister is going to write that as t to the 3rd, and she's going to put a 1/3 in front. Are these equivalent? Absolutely. Does it matter which one you do? No. But I'm just letting you know, she likes to write it that way. I'm a divided by 3 because that's how I learned it in high school kind of person. What do I need to do over here to make this in that power rule way that I can add 1 to my exponent? Yeah, you guys, this is -t to the -4th is what it started as, right? So just be careful. Until it's in that power rule, we cannot use our little add 1 to the exponent, divide by my new exponent. But because now it is, can we do add 1 to my exponent? What would it become? Yeah, added 1 to that exponent is going to get it to be a -3. Divide by that new exponent, -3. What?
Plus.
Minus the negative is going to make it positive. Where am I going to put this guy?
On the bottom.
On the bottom, so it would be a 3 on the bottom, a t to what power on the bottom? And then my minus the negative is gone. What am I going to put on top?
1. Plus C.
Braddock with the win. Braddock, keep it away. Here we go. This one is not in that exponential power rule form. Yes, Greer, say that again. He goes, I know. The derivative of inverse tangent is 1/1 plus x squared. Dang, that was a really good memory. What if Braddock would have said arctan? Great. If they both forgot plus C, I'm weeping. The reason why this works, the derivative of inverse tan is this. The derivative of a constant is 0.
It's okay.
Whose derivative
Cosine, negative cosine.
is sine?
Negative.
Isn't it negative cosine?
Let's see.
Are we going to forget and get our signs mixed up here? Because is the derivative of sine cosine, but the antiderivative of sine is negative cosine, because we got to think, whose derivative is sine? Oh, it's negative cosine. If you hate me for putting a t next to a plus sign, I don't blame you. How about this one? Very good. He goes, oh, that's another nasty one. Isn't that inverse sine? You're so right, bud. You could have? Let's see how we do. We're putting a lot of them together. We got this. Whose derivative is 3x to the 4th? It becomes 3x to the what over what? Beautiful. Miss Meister would write that as 3/5 x to the 5th. It's whichever you prefer. Doesn't bother me one bit, doesn't bother her one bit. It's the same diff. Let's keep going. Minus 2x to the negative 2 over negative 2. What's going to happen with a negative 2 on top and bottom?
Cancel.
Yeah. So what am I going to have left there? 1 over, you said it, Lai. Because, good question, this minus sign lie I brought right here, boop, and then adding 1 to my exponent got me a negative 2, dividing by that new exponent of negative 2, my two negatives canceled out.
Tangent.
Derivative of tangent is secant squared.
Plus C.
Nice. Let's try one more. Ooh, we used to really love e, because the derivative of e to the x was e to the x. What's the antiderivative of 2e to the x?
E to the X.
Yes! Whose derivative is 2e to the x? 2e to the x. Love it. Okay, peeps. Whose derivative is secant tangent?
Squared. It is, right? Secant squared? Is it just secant? I was right. So
This is why I like in unit, so we're coming up on the end of unit 6. And we're seeing these rules again. So it's just good exposure again. Ooh, how are we going to do this?
So make it x to the 1/2.
Make it minus x to the 1/2. You're saying put it in a power rule. Add 1 to that exponent, you guys.
3x.
X to the 1/2 plus 1 would be 1/2 plus 2/2 is 3/2. Dividing by 3/2 is the same as multiplying by. Dividing by 3/2 is the same as multiplying by 2/3. This right here is why Meister always writes the fraction. Now, okay, let me back this up. Ready? Graham, you might have written it like this. Dividing by 3/2. That's true, but they're not going to put that. Dividing by 3/2 is the same as multiplying by 2/3. That's why she's going to she always throws that fraction out front. What's up, bub?
You don't do anything with that 1/2.
Well, we added 1 to it. We added 1 to it, and then we divided by that new exponent. We got to knock out some rules. Woo! I gave you the derivative rule, which again, to Graham's point, I don't like this stuff either, Graham, because it's saying, oh, if this was, say, x to the 3rd, this resonates with you more as well as me. You're like, oh, the derivative of x to the 3rd is bring that exponent out front and take 1 away. You know what I'm saying? This is what we've learned, that is 3x squared. This is that in terms of symbols. I've done the same thing for you in an integral over here, okay? You guys, we got to work backwards. The derivative of kx, the derivative of 8x is?
K.
The derivative of 8x is 8. So the derivative of kx is k. So now what I want us to say is the antiderivative of k. I'm going to be formal, like Carrie hates, and put my dx just to let us know we're dealing with the variable x. Whose derivative is k? Very good, you guys. Plus c. Meaning, is the derivative of kx k? The derivative of c gets me nothing. I couldn't fill in the blanks here for you guys because then it would have given away this answer. What's the derivative of f? What's the derivative of g?
G prime.
So then what we got to say over here is the antiderivative of f prime plus g prime would get me what? Yeah, derivative and antiderivative cancel out, and we're just left with f plus g, always. Antiderivatives always have a c, as Dice pointed out, when we have no bounds.
There's not two, though. There's always just one.
Yeah, good call. Yep, just right at the end. A way to think about this, you guys, is a is just going to be a constant. What if I asked you, hey, what's the derivative of 8 sine? What would you say the derivative of 8 sine is? 8.
Negative 8 cosine.
Just cosine. Derivative of sine is cosine. So what would I say the derivative of a f of x is? A f prime. Well said, bud. So then how I'm going to rewrite that over here is the antiderivative of a f prime is just going to be, yeah, exactly. Very good. You guys, do you agree the derivative of natural log is 1 over x? Here's where we're going to get a little beefy.
Yeah.
Antiderivative of 1 over x, you're going to want to just say is natural log of x. Here's where I got to let you know. It's the natural log of the absolute value of x. And you're like, squeeze me? Let me show you why. You guys check this out. 1 over x is this blue graph. 1 over x is this blue graph. Red graph is natural log. Does my natural log graph exist when my x's are negative? Does the red graph exist when x's are negative? No. So, Nelson, when they say, hey, what's the antiderivative of 1 over x? Woo!
You okay?
Yep, all good. What are the antiderivatives of 1 over x? We can't deal with any negative x values. So we have to go say that it's absolute value because natural log doesn't exist for any x values that aren't positive. This is the first time you've seen it. Am I going to go over that 100 times? Yeah. This is more unit 7 that we got to worry about this. You guys, derivative of e to the x? Therefore, the antiderivative of e to the x is e to the x. Nice. You guys, what if it was 8 to the x? And I've showed you this rule. We don't use it much, but I just want to be thorough and give it to you. It's actually a to the x ln of a. And you're like, excuse me, right here, you didn't tell me to write e to the x ln of e.
Because they cancel.
Why didn't I? Exactly. So when that base is not e, we do need to note it. I'm going to give you this antiderivative rule. They've never asked it, but I'm just going to give it to you because I want you to have thorough calculus notes that you can refer to next year. If they ask for the antiderivative of a to the x dx, that's just going to be a to the x divided by natural log of that base plus a c. Okay, I want to practice these guys real fast. Let's remind ourselves, derivative of sine. Great, derivative of tangent. Secant squared, derivative of secant. Secant x, tangent of x, and derivative of cosine. Beautiful. You guys are very good. Maybe let's just get a little refresher today of those 4. I want to practice their antiderivatives. Yes, we will go over the others. They're not going to test us on these others. These are the 4 they're going to test us on, all right? So let me remind us. We're going to say antiderivative of cosine. You guys, you got to think, whose derivative is cosine? Yeah, and we're used to saying the derivative of cosine is negative sine, so we're going to get those mixed up a little bit, and that's okay. Whose derivative is secant squared? Good. Whose derivative is secant x tangent of x? Nice. And just make sure that we're putting some plus c's on all of these. Now I'm going to throw you off a little bit. Whose derivative is sine? Exactly. Nice, you guys. Could I have written that and said, okay, antiderivative of negative sine? What would that be? Exactly. So those negatives, it has to be on one side or the other. You know what I'm saying? They are interchangeable, but I didn't want to give my original as a negative, so that's why I went that route. Okay, those are the 4 we got to know. But you guys, we know that. We just have to start thinking backwards when we see that integral sign, which is not easy, you guys. I'm just going to, anyone remember this one?
1 over secant squared.
Now you cute. Negative cosecant squared.
Oh.
A derivative of cosecant is negative cosecant cotangent.
Me too.
What's up, bub? Again, if I want the antiderivative, I'm going to say antiderivative of cosecant squared. Again, you don't need to worry about these, but I just figured since we don't have a textbook, I want you to have all the materials at your fingertips. In college calculus, would they make you do these? Yeah. I just don't see it on the AP test, so I'm not going to worry about it. Exactly, sir. Negative cotangent plus C. And then, whoa, antiderivative of cosecant cotangent is negative cosecant x plus C. Oh, Greer's like, I already showed off with this one before. Whose derivative is 1 over 1 plus x squared? Whoo, it is inverse tangent. Inverse sine and inverse cosine. We love that the cosine is just the negative inverse sine. I love that. Don't forget your plus C's. I am curious, can you do this problem? No, next page. Can you do this AP question? Because it's got e's. It's going to throw us off a smidge. Try this one. I'm going to walk around. How I think of this, that whatever you choose, the derivative better get you what you started with. Yeah. What's the antiderivative of e to the x?
E to the x.
Okay, so I'm digging that we got an e to the x here, an e to the x here, and an e to the x there. I'm down with a, c, or e. They're expecting us to pick c. Okay, whose derivative is e? And e throws us off. E, you guys, you could just think about as any number we could make it a 5. Whose derivative is 5? 5x. So it's going to be e. A, I understand why you'd use a as well. The derivative of e to the x is e to the x. But is the derivative of a constant going to get me an e? What's the matter with c? What's the derivative of this e? Right, because e is just a constant. E is 2.718. Is the derivative of e, and you're like, wait, you've always said the derivative of e. Oh, it's when it's got an x with it. Because the derivative of e to the x is e to the x, because you got to multiply by the derivative of the exponent. What's the derivative of x? When I multiply e to the first, the derivative of e to the first is e to the first times the derivative of that exponent. That's why that guy's not going to work, y'all. Let's go on page 31, this guy. See if you can redeem yourself. And we're just going back to 1973, y'all. That's all. 1973. I want you to try that one. We can't. I don't know why I put it on here yet. Adding 1 to the exponent, dividing by my new exponent is going to get me there. Cool?